Let's calculate the probability integral. There are millions of different ways of calculating it. This time, let's use parametric integration. And so I'm going to let x equal to u times t, where u is bigger than 0. T is a new variable. So in that case, my original integral is 0 to positive infinity e to the, of course, dx becomes u dt, right? U. So e to the negative u squared t squared, then dt. The same thing. So if we just say, okay, this is a function in terms of u, right? In terms of u, but since still the same integral, right? So this is constant function in terms of u with respect to u. But so that way we say, if I want to calculate I squared, right? I squared. So again, let me just, can also be written into, I'm going to change x into u, right? It's still consistent. E to the negative u squared du. Still the same thing, right? So that I squared, how do I want to calculate I squared? I want to say I times this thing, right? Still the same thing. 0 to positive infinity, e to the negative u squared du, right? But that can be written into, so this I, I'm going to use this part, right? So I is a constant multiplied inside this integral. So 0 to positive infinity, this I becomes this, bracket, integral 0 to positive infinity, u times e to the negative u squared t squared dt, right, with respect to t. This is a constant times this part, e to the negative u squared, then du. And we can just multiply this part inside this integral, because this integral is with respect to t. So it has nothing to do with u, right? It's okay. Just treat u as a constant. Put this inside this integral. So that is first 0 to positive infinity, then the inside integral 0 to positive infinity, u times e to the, combine the powers together, right? Negative u squared, bracket, 1 plus t squared, I believe. Right, this is the inside integral, becomes this. Then dt, right, dt, then outside du, right? But this is a double integral, right? Then we change the order of the integration, right? We want to first integrate with respect to u, then t, right? So long story short, it is legal. Right? The proof of the legality can be found in any analysis book. So first, let me say 0 to positive infinity. First, I say 0 to positive infinity, u e to the negative u squared, 1 plus t squared. I want to do first du, right? Then I want to do dt. I change the order. So this time inside integral should be very easy, right? Just treat t as a constant, integrate with respect to u, and the antiderivative of this integrand is easily just, so copy it down. This inside here I have e to the negative u squared, bracket 1 plus t squared. I believe I should multiply by negative 2 times 1 plus t squared. I believe that's the antiderivative function. So evaluated, u evaluated from 0 to positive infinity. Right? Then dt. The reason is because if we differentiate this function with respect to u, then t is a constant. Using chain rule, easily just cancel out. Negative also cancel out. So derivative of u, right, equals exactly to this. So this is fine. Right, so u 0 to positive infinity. So positive infinity, right, u e to the negative infinity, just tending towards 0. Right? So this is fine. U becomes 0, 0 e to the 0, 1, negative 1 plus, right? Negative, negative plus becomes positive. So 1 over twice of 1 plus t squared, then dt, right, this time. And this should be easy. Right? This is, in fact, half of just arc tangent of t. T evaluated from 0 to positive infinity. That is pi over 4. All right, arc tangent positive infinity, half pi, pi over 4 minus 0. And so this is, in fact, I square. So in that case, I is equal to, just like we are familiar with, half of square root of pi.